Hi everyone, I am publishing a lot of blog posts about AI on my blog. The link is in the video description. Large language models (LLMs) have revolutionized various domains, from natural language processing to time series forecasting. However, one area remains largely unexplored, that is, their capability to detect anomalies in time series data. A new study dives deep into this question, uncovering surprising insights into how LLMs interact with time series anomalies. The study investigates LLMs' effectiveness in anomaly detection under both zero-shot and few-shot learning conditions. The researchers formulated key hypotheses based on LLMs' known behavior in time series forecasting and systematically tested these assumptions through well-structured experiments. Their findings challenge many common perceptions about LLMs and time series analysis, raising important questions about their strengths and limitations. Let us see their key discoveries one by one. First, LLMs understand time series better as images. One of the most striking revelations is that LLMs perform better in detecting anomalies when time series data is represented as images rather than text. This suggests that LLMs might leverage pattern recognition capabilities akin to vision models rather than traditional text-based reasoning. Next, explicit reasoning does not improve performance. Contrary to expectations, prompting LLMs to explicitly reason about time series anomalies does not lead to better results. This finding indicates that their ability to analyze time series data does not stem from structured logical reasoning. Next one, no strong link to repetition bias or arithmetic skills. It has been speculated that LLM's understanding of time series data might be rooted in their repetition biases or arithmetic reasoning. However, the study finds no strong evidence supporting this assumption, suggesting that their anomaly detection skills operate on different principles. Next one, performance varies significantly across models. Another critical discovery is the vast disparity in performance among different LLMs. Some models demonstrate better anomaly detection capabilities than others, highlighting the inconsistency in their approach to time series analysis. Now let us come to the question, can LLMs truly detect anomalies? The research indicates that while LLMs can identify simple, obvious anomalies, they struggle with detecting more subtle real-world irregularities. This limitation possesses a significant challenge for practical applications in industries that rely on accurate anomaly detection, such as finance, healthcare, and cybersecurity. The results call into question many prevailing assumptions about LLM's reasoning capabilities in time series contexts. While they offer promising insights into pattern recognition, their effectiveness remains constrained by fundamental limitations. This study opens the door for future research into improving LLM-based anomaly detection. One potential direction is integrating multimodal learning techniques that leverage both textual and visual representations of time series data. Additionally, refining model architectures to better grasp temporal dependencies could enhance their performance in this domain. For those interested in diving deeper, the researchers have made all synthetic dataset generators, final prompts, and evaluation scripts publicly available. The findings provide a fresh perspective on the role of LLMs in time series anomaly detection. While they show promise in understanding simple patterns, they are far from being a reliable solution for complex real-world anomalies. As AI continues to evolve, further research and model refinement will be essential to unlocking their full potential in this critical area. Thanks for watching this video.